Assalamu alaikum. Welcome to the next lecture on the Zbus building algorithm. In the last class, we were here as Vm is equal to summation g is equal to 1 to n Zmgij plus Zmik. Now, since we have derived this ik is equal to minus this, so that we can substitute the value of ik over here. So it gives Vm is equal to summation j is equal to 1 to n Zmgii plus ij Zmi into the value of the ik. So again, I expand this, it will be equal to minus over here. It will be Zmi divided by Zii plus Zb, Zi1 ii plus I1 plus Zi2 I2 plus Zi up to Zin in. So now taking after this, when I come over here, I will take I1 common and take the rest terms at one place. That means this will be equal to Zm1 minus Zmi into Zi1 divided by Zii plus Zb into I1. That is written over here. That is Zm1 minus Zmi into Zi1 divided by Zi plus Zb into I1 plus Zm2 minus Zmi into Zi2 divided by Zi plus Zb into I2 dash after this. So I can write it in terms of summation. So Vm is the voltage of all the buses apart from the ith bus. It will be equal to summation j is equal to 1 to n Zmj, because this will now change as per this j, minus Zmi independent of j. This is Zi1. Here this will be changed with j. These will be also independent of j. This will be I1, I2. This will also change as per the j change. So this is the final equation from which we can derive the Z bus. So I write this equation again. That is this one, equation 11. So it will be equal to Zm1 I1 plus Zm2 I2 plus Zm and In minus Zm1 Zmi divided by Zi plus Zb into Zi1 I1 plus Zi2 I2 plus Th up to Zin In. Let us say we have 3-bus system. I just want to modify this to get the this third bus, and by using the 3-bus system it will be very simple to calculate. This Zb is connected between bus 2 and the reference bus, since we are dealing with this type of modification, old bus and a reference bus. Is it so? Yes, old bus and a reference bus. So here I assume that the old bus is the 2 and the reference bus, and between the reference bus we are connecting in Z bus. So total n is equal to 3. Since I am connecting in between bus 2, that is I is equal to 2. That's why I will be now fixed. In the previous cases, that's why I am replacing this I with m when I try to find out the other voltages. So this Vm will be now equal to Zm1 I1 plus Zm2 I2, and n will be equal to 3 plus Zm3 I3 minus. This will be I will be equal to 2 Zm2 Z22 plus Zb into Z21. That is Z21 I1 plus Z22 I2 plus Z23 I3. So when m is equal to 1, that is the 3 voltages of the 3 buses. V1 is this, Z11 I1, and m is equal to 1, m is equal to here 2. Sorry, m is 1 over here. So m is 1 over here, rest it will be same because it depends upon the I. Similarly, V2, when m is equal to placing m is equal to over here, so equation will be like this. Similarly, V is 3, equation will be like this. Now I can represent in terms of matrices, that is V1, V2, V3. Then this will be equal to Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33, and then multiplied by I1, I2, I3. This is this matrix, that is this. Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33 into I1, I2, I3. That means this portion I have represented by these two matrices. That is this Z matrix and this current matrix. And this can also be represented by this Z matrix and current matrix. This will be 1 by Z22 by Z22 plus Zb. I will take it out. This will be equal to Z12 into Z21, Z12 into Z22, Z12 into Z23. You can see it from here. This will be Z12 into Z21, Z12 into Z22, Z12 into Z23. Similarly, this will be equal to Z22 into Z21, Z22 into Z22, Z22 into this should be Z23, like this. And finally, Z32, Z21, Z32, Z22, Z32, Z23. So this equation I can represent it the similar way, same way. there will be no change. Now this can be represented by these two matrices. This is the column matrix, this is the row matrix. When we multiply it, we get this matrix again. So I just do it just to make it a little bit simpler. Now you can, when you multiply this will be Z12, Z21, Z12, Z22, Z12, Z23, that is this row. Similarly, when we multiply this element by this row, we'll get this row. Similarly, when we multiply this element by this row, we'll get this back. So if you see, this is nothing but, this will be the second row of the old bus. That is, this is the old bus. Second row is Z21, Z22, Z23. And this will be the second column of the old bus. That is Z12, Z22, Z23. So here, by calculating the Z bus, you can see this will be the music, because here I have taken this I1, I2, I3 as common. You can see it here. I have taken this to this side. I have forgot to write out another bracket over here. So this becomes, because this will be a constant voltage multiplied by a constant into this whole constant will be the new Z bus one. So this Z bus will be equal to the old Z bus minus 1 divided by Z1, Z22 plus ZB into the second column of the old bus multiplied by the second row of the old bus. And when we simplify this, we get the new Z bus. So in general, so this is for the earlier case, Z bus old minus 1 divided by Z22 plus ZB into Z12, Z2, that is the second column of the old bus. This is the second row of the old bus. So in general, for an n bus system, and when ZB is connected between the bus I and R, so new bus will be equal to Z bus old minus 1 divided by ZBB, Zi plus ZB. This is the ith column of the old bus, that is Z1I, Z2I, Zi, that is Z3, Zii, and Zni. So here you can see this is the second bus, that is the ith bus, which we have assumed across this, and the reference bus, this has that is connected. Here is the ith bus, I will be over here. So here the changing parameter is the this one, 1, 2, 3, that will be equal to Zy. I will be constant, I will be this 2, 2 and 2. Zi1, Zi2, that is Zii, that is up to Zi1. This will be the ith row. You can see the order of this will be n cross 1, and the order of this will be 1 cross n. So n cross 1 into 1 cross n, it gives us a matrix of n cross n. So the order of this matrix is n cross n, the order of this matrix is already n cross n, the order of new Z will also be n cross n. So this is the third type of a modification. The fourth type of modification is when Z bus is connected between the two old buses. Let us say these two old buses are ith bus and jth bus. So it will be like this. So here let us say this current is injected into this bus as like this. So the current over here will be equal to II plus IK. Since this current is going away from this, that means some current is taken from this. This current will be equal to IJ minus IK. The current from this point is exactly equal to IJ. The current from this point is exactly equal to II. But the current that is injected into the ith bus, this is the point taken from the ith bus outside this box. So the current injected will be II plus IK. Here it will be II minus IJ minus IK. So VI will be equal to Vj minus the voltage drop of this, because Vj will be at higher voltage, because Vj we are assuming to be supplying current to Vi. So Vi will be equal to Vj minus Ij Ik into Zb, or Vj is equal to Vi plus Ik Zb. Let us say this equation 40. So, or we can say Vj minus Vi, that is the voltage drop between the bus I and J, will be equal to Ik into Zb. Vj will be equal to M is equal to 1 to N Zjm Im minus M is equal to 1 to N Zim Im is equal to Ik Zb. Here, usually in the previous class or in the previous classes, I usually represent this J is equal to 1 to M, but here I represent into I because I'm using J for the two buses, J the bus, ith and J, because we're connecting the ZB between I and J. So the alphabet I and J are already used. If I use it over here again, it will make some confusion. So I replace J by M over here. So this is like this, but I will take out the term in J is equal to I, that is summation M is equal to 1 to N, and M is not it should be here not equal to I and j. There are two terms because at this ith bus I has modified to II plus Ik, and at jth bus j has modified to ij minus Ik. I will take these two terms out. That's why I will not take m is equal to I and j. So all the terms will be summed up here, but except these two. So I will take these two terms out. It will be when m is equal to I, it will be zj I plus Ik, because at I will be equal to modified as II plus Ik, and zjg when m is equal to g, that will be equal to this zjg, that is m is equal to g here, zjg ij, but ij will be equal to ij minus Ik, minus this m is equal to 1 to n, that's I, that is z I am m is not equal to I and g. When it is equal to I, it will be z ii plus Ik. When z is m is equal to g, it will be equal to z ij minus Ik. This is equal to Ik plus Ik into zb. So summation m is equal to 1 to n zjmim, that is this. I will now add one more term to this, that will be equal to ii. Zjii will come out from this, and that it is added to this, it will be equal to, and zjjij will also come to this. So these two terms will be added to this, the summation will be complete, but it will still have two other terms, that is zji minus zjj into Ik, because Ik term will be separated out. Similarly, for this case, there are two terms ii zii and ij zij, that will be added to this to make the summation complete. The two terms remains, that is here will be equal to minus Ik, here it will be plus ik. So this will be like this. So finally, adding these two, this plus this, that will be equal to Ik. I will take Ik to this side, this ii will be plus, this zji will be minus to this side, this zji will be minus to this side, this zjj will be plus. So the total term will be like this. So from here we can calculate Ik will be equal to summation this minus this divided by this term. So Vi, that the voltage of other buses, voltage of the ith bus will be equal to summation m is equal to 1 to n. Ith bus is the bus at which we are connecting this Zb, Zim plus Zii into Ik plus Ii plus Zij into Ij minus Ik. So it comes out to be like this. This is when we take these two, when we add these two terms Zii plus Zij, and taking these two Ik Zii minus Ik Zij over here, they will be separated out. So summation m is equal to 1 to n Zim, Im will be taken outside. This will be Zii, this will be Zii minus Zij. So this is actually the same term, but I have first written Zii and then Zij and taking this minus outside. So Ik will be equal to this. Ik will be equal to this term Zmg minus Zim Zmg minus Zim divided by this. So this is like this. Now this equation is used to calculate the ith row of the Zbus. Similarly, jth row can also be calculated by putting psi is equal to j in this in 16. So this equation can be used to this. Now other voltages for 110 excluding Vi Vj can be calculated by Vp summation m is equal to 110 to Z Pm. Instead of I have written Pm, sorry, P Im plus Zpi into Ii plus Ik plus Zpj Ij minus Ik. So it comes to be similar equation as that of this. The only thing is that this I is the ith bus where we are collecting this Zb, but this Vp are the other bus voltage 1 to n except I and G. By doing the similar explanation which we have done for this system, you can see the equation comes out to be like this, and then we come up with this. You can see this is Zmg into Zij, Zmg into Zij, and they form the rows and the column and the rows of the old bus. Similarly, here you can see this will form the difference of the ith row and the jth row. Sorry, ith row and the ith column, jth column. This will form the difference of the this ith row and the jth column. So I can represent it with this. Here it should have been zpi plus zpj. This is okay. It should have been zim minus zjm, and then minus would have been here. Since I have written here a plus, that is why I have written here zgm minus zim. But in actual practice, it should have been, this will be zpm minus, this is same, zim minus zgm. So in that case, this will represent the difference of the ith and the jth column, and this will represent difference of the ith and the jth row, because m will represent the this I and j will represent the row, difference of the row, and this will represent the difference of the column. So I can write this Zbus like this. I will not further explain this equation by expanding it as I have done for this type 3 modification like this. After this, I just go for this equation and then finally derive it like this. It will be similar. This equation will be derived similarly. I have directly written now. This will represent the difference of the ith and jth column. This will represent the difference of the ith and the jth row. So the final Zbus will be Zbus old minus 1 divided by this. That is Zii, Zjj plus Zb minus Zji minus Zij multiplied by difference of the ith and the jth column multiplied by difference of the ith and the jth row. Difference of the ith column will be equal to Z1i when p is equal to 1, Z1j when p is equal to 1, Z2i, Z2j, that is Zni minus Znj. This will represent the difference of the column. This will represent the difference of the row. That is Zi1, that is this Zi1 minus Zj1 when m is equal to 1. When m is equal to 2, it is equal to Zi2 minus Zj2 like this. When n is equal to m, Zin minus Zjm, it will be like this. So finally, we have difference of the ith, the jth row will be this, and the z new will be equal to z old minus this. Difference of the ith, the jth column, difference of the ith and the jth will be 1. Actually, it should have been here since the place over here was not so much, so I have written over here. You should understand this should be divided after multiplying the difference of these rows and difference of these columns. So you can see it again here, the order of this matrix, whole matrix will again be n cross n. The order of old matrix will be n cross n. The order of this matrix will be equal to n cross 1. The order of this matrix will be equal to 1 cross n. When we multiply two matrices n cross 1 into 1 cross n, the resultant matrix will have an order of n cross n. And when we subtract two matrices of the same order, we get the resultant matrix of the same order. That is n cross n minus n cross n will be equal to n cross n. So let us try to do this by using a numerical. Let us say we have a 3-bus system. Bus 1, bus 2, bus 3, and this is the reference bus. And these are the impedances, actually reactances of the bus. I have omitted the J over here. You should understand there is J also. Let us assume that we'll start by adding the branch. Let's say this branch and then this branch, this branch. This will be an arbitrary choice, but I will use one of them, and I will use that in this class, in this example. Let's say Z old is 0, and we are adding Z bus 0.25 is connected between bus 1, that is new bus, because Z old is 0 and cross n is 0 cross 0, that means there is no bus. So 1 is the new bus and the reference bus, that is the type 1 modification. In this case, Z new is equal to Z old 0 column 0 rows of the old, because old would have only 1 0 0, 1 column and 1 row. So it will be 0 0, here it will be 0 because that old is 0, and 0.25. It is as good as 0.25 because since this is only one bus, there will be only one voltage at this bus and one current injected at this bus. That is why we have to represent like this. So this will be like this. Now Z old will be, when we use the other branch, Z old will be equal to 0.25. So ZB is equal to, now we'll see 1 and 2. That is, ZB is equal to 0.1 is connected between bus 2, which is the new bus, and bus 1, which is the old bus. This is the type 2 modification. Here I is equal to 1, K is equal to 2, that is new bus. This is type 2 modification. So Z new, so will be equal to Z old ith column ith row of the old bus zb plus zii. Ith row is same as, because it is 1 cross 1, I is equal to 1, 1 cross 1. So ith column will be equal to 0.25, ith row will be equal to 0.25, z old will be same as 0.25, and zb plus zii, zii is z11, that is 0.25, zb is 0.1. Total matrix will be this. So after that, zb is equal to 0.1 is connected between bus 1 and 3. Again type 2 modification, because here I is equal to 1, that is this one, 1 and 3. We'll use this branch. We can have used this one as 2 and 3, but I have used this one. Type 2 modification z new will be equal to z old ith column. Now the ith column of this is the z old. I is equal to 1, that is 0.25, 0.25 first column. Here will be 0.25, 0.25, z old will be this 0.25, 0.25, 0.25, 0.35, and this will be, it is ith row, that is 0.25 and 0.25, that is this. And this will be equal to zb plus zii, that is equal to 0.25 plus 0.1, that is 0.35. This is the z new for when we add this branch. Now we have to add this branch and this branch. zb is equal to 0.1 is connected between the bus 2 and bus 3. Both are old bus, that is type 4 modification. So in that case, what we have to do, that is the type 4, that is z old, z new is equal to z old minus 1 divided by, that is zii, because we are connected 2 and 3, z22, z33 plus zb minus z23 minus z32. You can see I is equal to, j is equal to 3, I is equal to 2, j is equal to 3, and this is the equation which you have to calculate. So difference of, what is the difference of this second row and third row? Second column and third row, the difference of this will be 0, difference of this will be 0.1, difference of this will be minus 0.1. So here it is 0, 0.1 and 0.1. This is the difference of the column, second column, third column. Now we have to calculate difference of the second row and third row. Difference of the second row and third row is this 0.5 minus 0.5 is 0, 0.5 minus 0.35 is minus 0.1, 0.35 minus 0.25 is 0.1. That is this. Sorry, I have 0.25 minus 0.25 is 0, 0.35 minus 0.25 is 0.1, 0.25 minus 0.35, because I have to go row 2 minus row 3. I have already done row 3 minus row 2. So the elements of this matrix and this matrix will be like this. When you multiply it, this and divide it by 0.3, because 0.35 plus 0.35 is 0.7, 0.7 plus 0.1 is 0.8, 0.8 minus 0.5, because 0.25 minus 0.25 is minus 0.5, it comes out to be 1 divided by 0.3. So after multiplying these two matrices, we get this matrix, and after subtracting this to this is the Z new. When we connect a branch between this and this, finally old bus and the reference bus. So when ZB is connected between the third old bus and the reference bus, that is a type 3 modification. Here I is equal to 2, ZB is equal to 0.25. So Z new will be equal to 1 by Z old minus 1 divided by ZII plus ZB. In this case, what is the ZII? ZII is 0.3126. And this is 0.25, because this is the second column. It is I is equal to 2, that is ZII will be equal to this is 0.3166, again the same. So when we multiply it, this is the second row, second column, this is the second row. You can see it. Second row is this, second row is this, and this is the second column. Second row 0.25, 0.3166, 0.2833. This is second row. Second column is 0.25, 0.3166, 0.2838, 0.2833. Like this. So when we multiply this, we get this matrix upon dividing this, that I divided by ZB will equal to 0.3166 divided by 0.25, and then subtracting this, we get this matrix. This is the final matrix which we calculate by using this Zbus building algorithm. So we're discussing that ZB is connected between the third old bus and the reference bus. Here I should be equal to 2, ZB is equal to 0.25. That means we need to find out, we need to calculate the multiplication of the sorry, this should be the second bus. This should not be third bus. I is exactly equal to 2. This should be the second bus, second and the reference bus, because there is no connection between third bus and the reference bus. So this is the second column. Second column 0.25, 0.3166. Here it should be like this. I have modified it. So I is equal to 2. This bus 2. 0.3166, 0.2833. This is 0.3166, 0.2833. This is the multiplication of this, and along with the division of this, we get this matrix. And after the simplification of this matrix, we get the value of this is the Zbus of the system which we have discussed. Now coming to the same topic, we will try to find out the Zbus by the current injection method. So in this case, so in this method, what we do, as I have told you earlier, we inject a current source I1 at the bus 1 first and calculate voltage V1, V2 and V3. We get by simply have the ratio of the voltage and this current at the 3 buses, we get the first column of the Z bus. Let us try to find out this column. The second column and third column you can do on your own. First, let us try to find out this when we insert a current source I1 at this bus, and this is the rest of the network, and we assume there is no other source except this I1. So this is a little bit simplification of this, because this will act as a series from this point to this point. So after series combination of this is 0.2, this is 0.1. The parallel combination will result in 0.062, 0.067, and 0.25 remains as it is. So this will be 0.067 plus 0.25. This will be the series combination equivalent reactance of these two, and the total reactance will be the parallel combination of these two. This will be the total reactance. Now V1 will be equal to this I1 multiplied with this reactance. So V1 will be equal to 0.1397 into I1. Of course, there should be J, because of this will be actually J. So since there are only reactances, if you use J over here or not, you will still get the same answers. But better is to use the J, so that you may, in the future, sometimes you may have resistance also. So in that case, you will not get confused. First, this is V1. V1 we have calculated. Now we have to calculate V2. We have to calculate V3. So for that, we have to calculate this I12 and I34. First, we will calculate I4. I4 will be calculated from this circuit. This I4 will be equal to 0.25 divided by summation of this 0.25 plus 0.3167 into this I1. So I4 will be equal to 0.25 divided by 0.25 plus this into I1. This comes out to be this. So from this, because this I4 is actually split into these two currents, I12 and I13, and these two currents will be decided by these reactances. So first, I12 will be equal to current division rule, 0.2 divided by 0.3, that is the opposite reactance divided by sum of reactances, will be multiplied with the total current, that is I4, will be equal to 0.2 by 0.3 into I4, that is equal to 0.2941 I1. Similarly, I3 can be used with the current division rule, that's 0.1 by 0.3 into I4, that comes out to be 0.14705 I1. Now all the currents are calculated. We can calculate now V2. V2 will be equal to V1 minus 0.1 into I12, V1 minus 0.1 into I12. Actually, this should have been J into I12. This I12 is the proportion of this I1. Here there is no J or anything else, because J and J will be cancelled out. So this I12 is without J. Here it should be J, but V1 is itself equal to J 0.1397 I1 minus J 0.0241 I1. There it means it has only J. So this comes out to be 0.113 I1. Here also we should have in J. So V2 will be equal to 0.1103 I1. Similarly, V3 can be calculated as V1 minus this I13 into 0.1, that is this I13 into 0.1, we can get this V13. So J 0.1397 I1, that's V, minus J, this is without J, 0.04705, that is called 0.125 I1. So V3 will be equal to this. Now all the voltage have been calculated. We can calculate from the equation 1, that is this equation. So V1 by I1 will be equal to this much. So simply that is equal to Z11. Z11 is equal to V1 by I1, that is equal to J 0.1397. Z1 Z21 will be equal to V2 by I1, that is from this equation we can get V2 by I1, that is J 0.1103. Z31 can be calculated as from this equation, that is equal to J this V3 by V1, that is J 0.125. So this way we can calculate the first column of this Z bus. So similarly you can put the this current source at other two buses as well, and you can calculate other columns of the matrix as well. This is a class assignment or class homework to you. I will see in the next class or interaction class other columns how you have calculated. Now the third one is the Z bus can be calculated by inverting the Y bus. So I have calculated the Y bus by the direct inspection method. You can see Z11 will be equal to, that is minus 10 inverse of 0.1 and minus 4, that is 24. Sorry, Z12 is the will be equal to minus into minus 10, that is 10. Z13 will be equal to minus 10 into minus into minus, that will be minus 10, and Z23 will also be this same. You can see Z11 will be equal to Z12, but Z33 will be equal to minus 10 minus 10, that is minus 20. So I have drawn the Z bus by the direct inspection method, and by taking the inverse of it you will get the same Z bus which we already calculated. I'll stop here. Thank you.